Okay, the screen seems to work. Welcome to, I don't think it's the first session, but kind of the first session. And somehow full, so thank you for coming. My name is Adam Bean, Java developer, working with Java since 1995, freelancer since 1997. One-man show, so I don't have company behind me, I'm just a singleton. Always was a singleton, nothing changed. So consultant. And what's wrong with me, I still like Java 8, and now I'm doing, I would say, 40% JavaScript and 60% Java. What's interesting, if you have any questions left, first Monday of the month there is free streaming. You don't even have to register, nothing. Just ask me questions, I will try to answer them, but it should be somehow Java related. So not everything, just Java related. Okay, and there are some workshops. If you would like to know something about Java or HTML5, come to Munich. There are lots of people from Poland, actually. And now, if you cannot come, this is online. And now start. I just created 2 slides, actually. Because the first question is, what matters to me, or what is the context of the project, what I'm doing? I guess I was last year here and already talked about Java and microservices. Now it's 1 later. What changed, I spent a lot of time in projects with microservices and Java and Docker. And I would like to show you today what we did so far. And it changed from client to client, but not a lot. And your job is to criticize me and find something which is too complicated, too slow, too ineffective, too whatever. So first, what really matters to me is productivity. So if we are not productive in Java land, we will be killed by all the others. Probably not by assembler, but I would say JavaScript, there's Node.js or whatever. So if we find an esoteric solution, which needs 50 frameworks and 2 weeks to set up, no one will use it. I forgot to mention, my clients are not like Twitters and Facebook. I actually never was at Facebook or Twitter. My clients are larger enterprise companies like banks, insurance, automotive, whatever. I performed some interviews on my blog, Commerzbank or whatever. So I interviews on my blog, so you will find out what is actually the context. So simplicity is the key to success. So why many J2E and Java projects die was because of, I would say, not crazy architects, too theoretical architects who just thought in layers and mappers and forgot about the business logic. So if we keep it this way with microservices, like introducing 50 microservices because we can, and no one understands how they operate, this is the beginning of the end. And in 2 years, we will meet here and say, no, microservices suck, now let's build macroservices or whatever. So, or monolithic architectures. So I would say it has to be simple, and you have to reason to implement microservices. The next time is build and deployment speed. This is related to the first point, what it actually means. If it takes forever to build the microservice and start up, forget it. So I don't know whether you remember. Who remembers Xdoclet? This is our museum technology, exactly. So it was like, sometimes it remembers me to today's microservice technology, where run 5 minutes something to see hello world on screen. So this is what I think it is not viable to introduce such a thing in projects. And stock technology standards. This is very important to me because I'm singleton. If I pick whatever, I always get the question, why not this? But if I stick with the standard, because of, this is a law even, it's called Parkinson Law of Triviality. It says the more trivial the decision, the longer it takes to decide. So what it means, if there is no decision, we stick with stock technology, like I would say Docker on Linux is stock. Why do something else with one command we can install Docker? Then there is less discussion, less meetings, and we are more productive. And DevOps compatibility, or I don't know whether it is actually such a word like operability. If it is, I meant that. And what it actually means, it should be explainable to the admins and should be compatible with the DevOps movement. So this is my ideas. I probably forgot something, as like monitoring and everything else, but monitoring is, for instance, DevOps compatibility. If there is a black hole and we only see, the heap size, this is not DevOps or operation compatible. Agreed? So then, does they matter? For instance, what I heard on conferences, but never in my projects, like RAM consumption overhead. What I heard, people were concerned about RAM overhead, like, no, I tend to use application servers, like, oh, you cannot use my application servers because of the overhead. And I asked them, what's the overhead? I never got an answer. So I tried to measure the overhead, what turned out between all application servers on the market, whatever you choose, and Hello World Java. So, Java main, Hello World, what's the difference? 50 megabyte of RAM. So I keep asking, we in my projects, we have 10 microservices, 20 microservices, and let's imagine in worst case, we get 50 megabyte overhead per microservice. Does it matter to my client or not? I had some conversation with vendors, so microservice vendors, they were very concerned about the density. It's like, really, no one is concerned in my project. We have a project of 10 modules or 10 microservices, then we lose 500 megabyte of RAM or 1 gig. Never. Why? Because RAM is cheap. I bought recently for my Skylake, for my new machine, cost me about 400 euros, 64 gigabyte of RAM. The RAM from Skylake, 2133, what is it, megahertz or gigahertz or whatever, but I just remember 2133 is almost the fastest one. Okay, so the next question is, image and file size doesn't matter. So it doesn't matter, then the Docker image is 200 megs, 50 megs, 30 megs, or 50 megs. Or 500 megs. And I never heard the latter. So no one asked me how big is the image on disk. Sometimes I hear the concerns about the RAM size. So what I wanted to tell you, even if it would matter, if we choose how it's called, heavyweight solution like application server, we will lose 50 meg per Tommy, WebSphere, Payara, Whitefly, or WebLogic. If you cannot believe this, go to my YouTube channel. I just recorded everything because on paper everything looks nice. Like, okay, I will record it live and just show the Docker stats, what the overhead is. If you have questions, just ask questions immediately, but not too much. The last two talks went completely wrong because I just questions all the time and cannot show anything. At this time, I'll try to code something. Okay? So these were the slides. So this is the last slide. Thank you. I also wrote books, and there are some, marketing. There's my blog, by the way. And OK, now we can kill the slides. And now nothing can go wrong because now just code is left. OK, everyone agreed? This was my context. And most of my clients are enterprise companies, and more people, even some Polish startups, hired me to help them with starting a microservice project. OK, how it starts? I will just hack something for you and then explain what I'm doing. I'm just building this one, something, and I will explain you in a second what it actually is. Let's call it client. Bigger. You are young people. The Java developers are very young. Bigger. This was wrong anyway. This was wrong project. Delete. Bigger. Okay. Font and colors. This is. It screw up my windowing. In full screen, I cannot make it bigger. So the first, if you start with microservices, set up the font first. This is the most complex task. Everything else is easy. So make it bigger and 18, double the size for you. We are all older, right? So if this were a talk about Node.js, I would be asked, can you make it smaller, But so now I call it differently. It's a Devoxx. So looks nicer. And so as you, oh wow. Now I have a problem. I don't think anything. So I'm using Java 7, but it shouldn't matter. So forget about this. You won't see it in the duration of the course. You can just do whatever you like. We just always use Java 7, but it's the simplest possible choice. I was in some selections, and it always won. But forget it about this. I would just implement something and deploy it on Docker and make it communicate and answer some questions. So what's nice first, the POM is small, which means simple. And what's nice with Java 7, just on, we don't have any external dependencies. What it means, the image is small and fast. So why it matters? The Jenkins build pipeline has to execute fast. So I was in an enterprise project where it executed for hours. This is not wrong. This is not continuous integration. Integration can be called continuous if it is done in seconds or at least 1 minute, but not hours. Okay, so the builds process would work like that. And now it's built, and I would create a REST endpoint. So actually everything is REST. pl.devoxx messages resource. Just do it. I never had such a font, I have to admit. Hey, good morning. It's just a quick test. Run it. And nothing micro with it, but I will start immediately with the first feature. I just wanted to do it from scratch, that you see the full process. And so it starts everything. The first time takes longer, then it's faster. The most asked question is, do I use Docker for development? And the answer is usually not. It's not needed. No one uses that. But if no one in my projects uses that. This is what I wanted to say. What we need Docker for is for test databases or starting the surrounding microservices, mocking up the environment. But our microservice, which are developing, is not running on Docker. What was it? Messages or messaging? Messages doesn't work. Why? Because I forgot get. This was the first test for you, whether you are awake or not. Good morning. So nice, right? So what I wanted to show you with that is the following. Because all application servers, now is the first microservice relevant thing, have to implement something called JSR 77 for 13 years. It is a forgotten thing. I'm able to emit monitoring data. This is like my Devoxx project server. And you see some error counts, and you see some stuff available as JSON, available as XML, all the boring default HTML. So, and the first, I will come back here. So this is what is forgotten. What I saw in project, people are tempted, to integrate histories or whatever to get the statistic boards, but this is actually the essential added value of application servers. So this is available in Whitefly, WebSphere, WebLogic, whatever. So mostly we use Payara, Tommy, and Whitefly. But so it might be a little bit boring. So you see here just Devoxx server. But what I will do, a little thing, I will say you are stateless, which is a kind of cool technology. So microservice capable. We reload that, and what you see is, because this is what I did is an EGB, I got additional statistics. We use it all the time. So the entry point to microservice is something annotated with stateless. What it is doesn't matter. So what we get here now, we see how many of the things are created and removed. Removed means exceptions happen in background. Created means how many parallel transactions or requests happen per second, which is very important for microservices to know what's going on in your server. And the bean methods is you see the method hey, and I will just go here and say good morning. And we see the method was executed several times. So wait a second. You can actually count 7 here. Just method statistic, of course, available as JSON. And this is very important because we always create a quick dashboard to see the statistics and to see there were no errors and the method was called 7 times. So I got the question all the time, so why I'm putting that stateless on my REST resources? And the answer is because I like to have statistics built in without any additional frameworks. And I got the statistic from all application servers in real time. This is live, no preparation, just stock Payara. I could do the same with Whitefly, but I forgot the command line interface. There's the same command line interface. It was always available actually in JBoss. Okay, so now we have that, and now let's just thinking. We saw the monitoring. Oh, by the way, at stateless, it is also faster if the microservice is getting more complex. Why faster? Because the dependency injection behind the scenes happens only once, and I get built-in throttling. What is throttling? Microservices is pretty important that you should not be able to overload a microservice. What I can do with stateless, I can say max pool size 50, and there will be never more than 50 concurrent connections at the same time, which solves the problem elegantly. Agreed? Cool. So 2 annotations, and by this, because I will just clean and build it again. Devoxx. And this is 3K. So the whole microservice, the war are 3K. So some of you could say, yeah, it's 3K, but you cannot run it. So I cannot say, Java minus jar Devoxx war. Yeah. This is not a fed war because it's tiny. So you could say it is no anti-pattern because microservices were supposed to be fed wars. I never got it, or the fed jars. Why did I have to be fed? So what's the advantage of application servers per accident? So it was, I think, never meant that way, but it fits perfectly in microservices. With application servers, there is a strict separation between your business code and the infrastructure. And I can say, okay, who cares about that? And the answer is Docker. So, and I will show you something, what we always did, and this was actually the key to success with stock technology. A project Docklens, you can actually clean it on GitHub. What Docklens is like the simplified version of Docker installation, of Java Docker installation from my project. So internet seems not to work fast. You are all in Bitcoin and BitTorrent and whatever. So Docklens, here is it. So now the idea, look at this. So we start with the first image. This is Docker. What it basically is like a Maven POM, and each command is one commit. And the first command installs the Java image from CentOS 7. The next image installs Java 8 and cleans all. So it makes the image a little bit smaller, and then Java 8 is installed. So after running this, I get a Java image, which I can immediately, execute with Docker run. I think it was airhex Java is the name, and Java minus version. You see this OpenJDK. If I do it on my machine, it is different version. So I executed in this first image. I just show me the Java version. This was the Docker command, and started the CentOS, executed Java, and returned Java. So the nice story is, the first thing is built by operations. Why? Because they have the SSH keys, whatever infrastructure, security frameworks, whatever they have, they put it to the operating system image. If the operating system or Java has to be patched, they just build the image and push it to Docker registry. So the next thing is, for instance, Whitefly. So and now comes the nice story is that the Whitefly image inherits from airhex Java. So the first image is built, and this image extends the first image as it's only built in case Whitefly changes. And I did the same for Payara, for Tommy, Webs to Liberty, whatever. So it is always the same story. A small convention, I tend to use the, I think, deployment folder, deployment dir, which is common for all images. And now the cool part. So if we create our microservice, we inherit from the application server. And where is it? For instance, Whitefly pink here. And this one inherits from airhex Whitefly, or airhex is like the domain name, like Devoxx Whitefly or Devoxx on Devoxx Payara. And then just copies the ping to deployment folder, or you could, of course, use the command line interface to deploy. Usually we do this, it's simpler. And now the cool part, this is tiny. But we do this all the time. So on the Devoxx pipeline, we only build the operating system of Whitefly when new release from Whitefly is available, but we create on each commit the microservice over and over again, and this is crazy fast. So now try that. So I will just steal this and try to run our Devoxx microservice in Docker. So I will just copy from Workspaces, Docklands was it? Yeah, Docklands, whitefly pink. The Docker file, here, not here. Okay, here. And then copy it, hopefully the root folder. Perfect. So I have the Docker file, and now I could build the system, but before I build it, I would like to edit the file. And this is almost, it's not pink, I guess it was Devoxx, and it was Devoxx, target Devoxx. So I prefer to do everything from scratch. I did prepare anything. Of course, in project, you wouldn't have one Docker file. Everything runs on Jenkins pipeline, but it's really simple to set up. If you have questions, of course, ask. So, and now build the image. Watch this. Docker build -t, Devoxx, Devoxx, this was a little bit strange, or call it microservice or Microsoft or whatever, .build. This is the speed we build microservices with application servers. Everything else I know is a lot slower. And this is the reason why I use microservices everywhere with stock technology, because need of speed. So this is need for speed, need of speed, need for speed. And you can say, well, you built it before, so let's do the ultimate test. Minus, I think, no cache, or with one minus, wait a second, no cache, I guess, 2 dashes. So, and now let's see the same time. So it takes around 150 milliseconds. And if I go to Docker images, it's built 11 seconds ago, and the full image is 700 megabytes of RAM. You can say, yeah, it is huge, but I think agreed with me, it would be impossible to build 700 megabytes regardless how fast my disk is in 100 milliseconds. It's impossible to do it on laptop. This is why virtual. How Docker operates is the first Java image is built once and it never changes. On top of this image, as a whitefly image, built second time, it never changes. What always changes are 3 kilobytes. So if I build it 100 times a day, I wasted 300 kilobytes of hard disk space. This is the advantage of thin wars, and I don't care about hard disk. As I told you this already at the first slide. We care about speed. Okay, we can launch it, hopefully. So Docker run in detach mode. Let's use a port 81. I think this is the stock glassfish. So let's 87 something strange. 8780 and 8080. And this was Devoxx. Let's use a name dev. And it was Devoxx, I think, MS. So launched. Docker logs. Dev. So you see, it's deployed. So this was the true experience from scratch with just Maven, nothing else, and IDE of your choice. So, and let's try to ping that. It was a different port number because I don't have the native Docker installed. I just have the, oh, by the way, this is the emulated version of my notebook. It runs usually faster. What happens here, it actually runs in VirtualBox. So the native installation would be faster than this. 8787, what was it? Devoxx, I think. You see already, forbidden is a good sign. And then resources, messages. Good morning. So this was the full cycle developing a microservice with monitoring. What I skipped is whitefly build. Why? Because I will have to pull it from the internet. It will take 2 minutes or something. So I prepared that, or I use it all the time in my projects, and created a microservice. Questions about this? Shout. Very loud. Very good. This would be database connection. I don't have database prepared here. But I will try to communicate to microservices. If you get the idea, then you will know how to add the database connection. Agreed? So how to configure the application server that is able to talk to database. And the additional challenge is we don't know the IP address, right? This is the problem. Okay. Then, to demonstrate you this, I would like to start a microservice. It's called microservice, a project called Headlands. This is just exposes something via REST and try to, or we don't have to do this. Wait a second. It runs now here. Okay. Now create a Devoxx client. I'm just answering his question with code. Easier than slides. So, and I will call it Devoxx client. And this client is supposed to run in another container and communicate to the first one. Okay? Devoxx client looks nice. So we have it. So, and now I just have to look up Docker PS, the Docker name. And the Docker name is dev. This is the important thing. So what I can do here, I can say the following: new Java class, and also say here PL Devoxx. What messages? What I can do here? Messages. I have not very creative message. Breakfasts. Breakfast resource. Breakfast. Almost Belfast. So path. Break. String. Communicate. Never forget this get. And client builder. New client. Actually do it right. So init, post construct, and this should be stateless for monitoring. And the client, what we get the connection endpoint from the other one, this client, and create a field. So we have it. And then we say this client target, and this should be the URI, and I forgot the URI, is this. This client dot, and this is the URI, target. Now the problem is, this is not right. So the resolution, the font size is a little bit crazy. So this is not right. Cannot be right, the IP address. But the cool story is, what we have to use 8080, and instead of the IP address, we use the container name. And the container name is dev. So dev 8080, container name. And then the target, we get the target, is the service. And now hopefully we can say return this service, request, get, string, from MS to MS. Nice pattern, MS to MS. So request, get, string, communicate, should work. So I would just build this, and then your question was not really nice, because copy, I would have to copy the Docker file and change it a bit. So why? Why? Because, but it will actually, I wanted to show you anyway the communication between microservices. What I would like to do is to go to the junk folder, to the Docker file, and say Devoxx client, I think. Devoxx client, hopefully, and build that. So, build, and this was Devoxx. Let's call it Devoxx MS client. So it's built, and now we can run it. And now it won't work. If I will start it, it won't work out of the box. But what we have, I can say I create a network and call it Devoxx. Docker network ls Devoxx. And I can say Docker network Devoxx connect. I think the first was dev, right? Connect Devoxx dev. Docker network inspect Devoxx. And you see, we have one container in the network. What I will do, I will launch the second container in the same network, and these two containers could securely communicate within this user-defined network. It's a standard feature. I got the question all the time about, for instance, service registries. We never used any service registries. Docker in the enterprise, this in the enterprise was good enough. So to communicate directly. And what we can do, we can swap in milliseconds between IP addresses or microservices. Okay, now launch the second one, Docker run. And let's call it 88. And what you can say, I would like to run it. I think net Devoxx. So I launch this microservice in the network Devoxx. And the name is dev client and ms minus client, right? Is it? Looks right. Okay, Docker PS. So we have two microservices running. The one name is Docker MS with the port 8880. So 8880, not messages, rather than break, and this was Devoxx client. So this was communication between two microservices in user-defined networks, deployed and started on stock application server with built-in monitoring. Each of the microservices is 3 kilobyte. The build time is 100 milliseconds. And the large operating system was built only once and is rebuilt on every patch, usually at most, I would say, once a week. So how to deal with databases? This was actually, you would use or in real world, I forgot something to show you. So on conferences, you should be happy with this. But if you come back to projects, you will need something like this. This is a Payara example. We inherit from the official Whitefly or Payara image, and we put our configuration here. And this is like data sources, if we have JMS queues, and whatever. And how to talk to a database, you will set up a data source, and there is no IP address, is the name of the container. And the name of the database is going to be resolved by Docker at runtime. This is what we are doing, and there is, you can have immediate containers or whatever, but this is how to deal with links between microservices. Instead of using IP addresses, we use container names. So this was where my clients were very satisfied. If you are not satisfied with that, there are specific microservice registries for Java EE, several, but we never used this because this was good enough. And I'm not running, hundreds of microservices rather than a small amount of microservices. Even large project, we have 10 microservices. And what a microservice is, a focus, one pizza team creates one war. Done. Are you perfectly happy? Nice. So then, introduce some patterns. So we have our Devoxx client, and I would like to show you how to increase the resilience. So, Jersey timeout. So this is two very important proprietary settings, but they are available for all JAX-RS clients, and I hope they are going to be standardized in Java 8. So connection timeout and read timeout, very important. If you not specify a timeout, if you communicate between application servers, microservices, it's a really bad idea. What's the problem with that? this is just proprietary setting, and I would like to change that, or to change this, you have to add the properties, Jax rs dep, and what I only need is, because I'm using Jersey behind the scenes, is Jersey, but the nice story is, of course, provided, never runtime. So, and now I will just recreate that. Save it. So, no dependency. You are not helping me this time. Usually, the audience is nicer. Say, hey, you have twice dependencies or whatever. So, this time, everyone hopes that nothing will work, right? It's like, okay. We show you what it effectively means here, right? So, hello world and nothing works. So, this can be configurable. And how to configure such things, usually you would use injection. So instead of using like this, you will just produce the values. And, pretty important. What you will do is, for instance, something like this, inject int and say this would be connect timeout. And then we would create a configuration component. And this would be here. Configuration boundary, and the name is going to be configurator. So, int expose injection point. With injection point, I get the metadata where the thing is injected. I can produce it. Then from there, and you can say, okay, what's the deal with that? So the cool story is, with Docker, we use this. So if you launch Docker containers, you can specify system properties which become variables. And we use that to configure the whole Java EE app using exactly this system get.env. So what it means, what we can do here, we do something like this, IP get declaring class, get member, get declaring class, and we know where it is injected. Class, and then IP get member, get name, and this is the field name, and then something like get or default, and the key would be, of course, string key like class dot get name plus dot plus field name, and in this time field name, and the default would be, of course, 42. This is why it always works, and then integer dot parseInt. Of course, we would provide, a method for everything, and this should be a string. So, and what it basically means is, usually you would say, okay, but this is not very robust, because if the injection point changes, I will have to change the code everywhere. Usually we introduce an own annotation like config key or whatever. Just think about whatever you like. But the point is, we can change whatever you like from Docker. If you start Docker, there is -e setting, and you can specify the key value pairs or even a full property file, which is read by Docker, and make the all the things injectable. So point is, connection timeout here could be configured, has to be configured. And now the question is, okay, but let's say, what about the patterns? So bulkheads and circuit breaker. So the nice story is, with circuit breaker is already built in. So what would be a circuit breaker? Let's say I just introduce a class which is unstable and slow. And this communicates, in one project it was a SOAP service. So SOAP service killed us. If you don't know what SOAP is like, there was nothing to do, and people who had Java got the idea to sail us everything to ASCII with lots of stuff and put it to Java again. So the project were busier. Now it's almost no more available. So just in German museum or in Polish museum. So what we have, a singleton, and this is slow. Slow execution. Thread, sleep. 1 second, it's enough. So now, this is slow, and and this is this should be a placeholder for communication with another microservice. So what you can do very easily, you can introduce a circuit. I always get it wrong. Just breaker. So and this would be object check stability around invoke. I think it was invocation context. And by the way, I'm writing everything from scratch here in 50 minutes. Usually we have all the stuff already. Return IC.proceed. But the cool story is we can just go here and say unstable and slow interceptor breaker. So, breaker. And what's the problem here? Session. It's not session. Okay, doesn't matter. So what we can do here, long start. System, current millis. Try. Finally. Okay, and then say long end or duration equals system current time millis minus start. And now we can now see here we can go here and say atomic long too slow. New. This is daily build IDE. And the reason for this is nice Docker view of all images, of all containers, and Docker syntax highlighting. It's not available in the release of NetBeans. Atomic long, and nice JavaScript support. So, atomic long 0, and we say if this is too slow, if duration bigger than 900 milliseconds, then it's too slow. Then, what we have to do too slow, increment get. And now we can say if, this is cool, so we can say here, if too slow, get larger than 3 times, larger than 3, return null. Circuit breaker. So what it means, if we communicate with external services, we have the access to performance, we have the access to exceptions. What is lacking a method called reset, so we can reset the state. And this is what we do in all projects was better than enough. One project tried to go fancy, with logarithmic attempts or whatever, but I would say keep it simple. In usual enterprise, we are not Netflix. It's not like, the servers are coming and going and everything fluctuates. It's like more, the service has to be up all the time, usually. So if you don't manage to ping the service 3 times, just escalate the error, send a CDI event to operations, say, hey, something is unhealthy here. But the cool story is this service will keep to operate. And what's also cool is the context of the atomic long depends on the class. So this unstable and slow is a singleton, so we only get 1 instance of the atomic long. So this was circuit breaker. Now bulkheads, also built in. Nothing to do here, so I will show you this. So what you can easily do, let's say this takes forever, and we communicate with lots of services, and we have to protect our clients because of this. So what you can easily do, I could say, okay, let's refactor this. I will put this in a method. Invoke business logic. Usually this is a second class, so I don't try, to show you too much of injection, just focus on microservices today. So this will return this. Okay, and now what we have here is the following. So we can say suspended async response. Async response. What this does is it immediately, how it's called, delegates the control from the HTTP thread to a thread pool, so the server becomes responsive all the time. And if it takes for 2 hours, the connection will block, but the thread is going to be parked for 2 hours, so you won't be able to kill the application server. So it's available forever. This is NIO2. Okay, we have that. And if you look at the response, what we're interested in is Settimeout first. We can say, okay, it should take no longer than not 5 days. This would be, let's say, seconds. Would be okay. And now already we get error service not available. If it takes longer, we can also set up a timeout handler. But what I'm really interested in is this: resume. So if I put something here, resume, I get, what happens then? The connection will awake and will push the content back to the client. And the nice story is the method resume is actually a consumer of objects. So and now the cool story is Invoke business is supplier of strings. So you can build supplier equals this Invoke business. Invoke business. And supplier is not imported, it's just Java 8. And now we can say completable future. Completable future. Supply async, then execute, then accept consumer. Fully asynchronous pipeline. Semicolon, very important. Of course, we can skip that and import it statically. And this is just for you. Usually I would never write this, it would be 2-liner. And now comes the cool stuff. What you can do, you are injecting and thread pool, which is monitored. And you can say, please execute this in my thread pool. And the managed executor service is a monitored and managed thread pool by application server. And if you go to the admin console, we could configure this and say, okay, you can do it from command line, of course, or usually we do this in Docker. There are concurrent resources here. Managed executor services, and this is this one I'm using. It is not well configured because it is infinite depth. But what I could do, I could say, just 5. So what it means, this is one of the microservice patterns for each I/O communication channel, whatever it is, whether it's database or another service, install a dedicated thread pool, which is already built into application servers. So why? All my projects are Java EE and microservices because with stock technologies, without any additional framework, we would able to implement all the microservice patterns plus 12-factor, how it's called, 12-factor apps, right? This from Heroku, I think. So we were actually microservice cloud native, and most of my projects looks like that right now. Okay, I think I'm slightly over time, so I'm really thank you not asking questions. So the first time I can show something, I'm not very satisfied. I could wanted to show more, but just 50 minutes. So please ask questions now if you have any. Yeah.
What about type safety between the services? How would I provide type safety?
Yeah, this is a long answer. Usually we don't like to be type safe. What we do, we use JSON. just JSON object, never string, what I did right now, but it doesn't matter right now, so I use JSON object. And what we do, what I also skipped, but I think I showed it last year, we use system tests to ensure the compatibility between microservices. And how it works is you would write a system test, put it to Jenkins pipeline, and if any microservice changes the interface, you will break your system test. This is what we are doing in project. It works well. Type safety is not a good idea if you have, in true microservice world where you don't know the other team, because each minor change of the type breaks all the services. But this is a longer answer. So this is what a minimalistic answer. In Munich, I think we spent 2 or 3 hours just discussing this at the workshop. So, but you can ask me afterwards, so we can discuss a little bit. Okay. Other question? Yeah.
How would you integrate other services that don't have control?
Other service which what?
Don't control yourself.
Yeah, this is always the case. For instance, in my current project, we had to use an old SOAP service, which caused lots of trouble. So what we did, we created a POJO, which accessed the external service and applied the circuit breaker exactly what I did right now. So if you the class, how it's called, unstable and slow, is a placeholder for external service outside our control. So it was exactly the same. So there's no difference. And if you have to integrate, POJOs, which are not Java EE capable, use producers. You can inject whatever you like. No limitations. Even native code, whatever you think of. Thank you. Very good. Other questions? What? What monitoring? Trend.
Yes, because so far we've seen
They like fashion.
regards to a snapshot, right? So we've seen that a particular method
Yeah.
has been invoked 7 times so far.
Yeah.
But I wanted to see how it behaved over time.
Very good. What about trend monitoring and how to deal with that? Usually it is in enterprise. We have Nagios and everything shown well integrated. What usually happens in microservice world, we integrate more sensors, so more output data. And if you're interested in trend, look at the old project of mine. I think it's already 7 years old. It's called Lightfish. What it does, it just connects to the application server, gathers the monitoring data and stores it in a broad table, nothing else. And it's already used in production several years. But I would never build it from scratch. I would store it somewhere. And what we usually do is, we use Logstash. Is mine with Kibana is a little bit. And if you need real trends, the question I would ask you what you're interested in. We would define a use case. What is audit trail? What is it? And then we store it in a database. And then we probably a microservice which exposes the trends. But if in one point, you will have to introduce a little bit of AI, artificial intelligence, to watch the trends and do something about this. But what I show you today is how all my microservices project starts. Customers were happy so far. The productivity was great. It was extremely simple. And in one project was nice. We never mentioned microservice. And I sent them an email afterwards to say, actually, what we did with microservices. And the answer was, OK. So this is how it should be. So thank you for coming and enjoy Devoxx.